to my video demonstration of my PROG7312 POE Part 1 Municipal Service application. First, we will go through the code and then showcase the application. First, we look at the issues linked class. Its job is to store and manage a collection of issues using a linked list structure instead of something like a normal array or list. The private fields, issue node head and int count. Head points to the first node in the linked list. If the head is null, it means the list is empty. Count keeps track of how many issues are currently in the list. The add method inserts a new issue into the linked list. It creates a new node using the issues object we pass in. If the list is empty, that new node becomes the head. If the list already has items, we loop until we find the last node and attach the new node to the end. Finally, we increase the count by 1. The count property, this read-only property, it allows us to quickly check how many issues are in the list without directly exposing the private count variable. The getAll method, this method lets us loop through the issues in the list. We start at the head node while there's still a node available, we will return the data stored inside it. This makes the class easy to use in a for each loop because it behaves like a collection. Next, the issues repository class. This is a static class, which means you don't need to create an object of it to use it. All members inside are also static, so they can be called directly with the class name. Its purpose is to act like a central storage or repository for all the issues in your application. Private static fields. Underscore issues is a single shared instance of the issue linked list. The read only means it can only be set here and won't change to a different list later. Since it's static, the entire program uses this one linked list to store issues. The add method, a shortcut method for addressing issues. Instead of creating a linked list yourself, you just call the issues repository.add new issues. Internally, it passes the issues into the underscore issues.add method. Count property just gives back the total number of issues in the repository. This just exposes the count from the underlying linked list. The issues property provides access to the underlying issues linked list. This allows the other party of the program to fetch or loop through all the issues if needed. The issues class, this is a plain C# class. It represents the actual data structure of an issue in the municipal service system. Each property describes some detail about the issues being reported. The ID property, each issue automatically gets a unique identifier. The guide.new method ensures every new issue has different ID useful for tracking. The create@at property stores the timestamp of when the issue was created. By default, it is set to the current date and time. Location, a text field to describe where the issue is happening. Example, Main Street, Cape Town. Category groups the issues into a type. Example, water leak, road damage, electrical fault. Description, a long text field explaining the details of the issue. For example, there's a burst water pipe causing floods near the school. And then attachment part stores the field path of any photo, video, or document attached to the issue. Second to last class, the issues node class. This is a helper class used to inside the linked list. Each issue node holds a single issue and a reference to the next node in the list. Together, these nodes link up to form the chain of issues. Data property stores the actual issue object. This is a core data like the location, category, description, etc. Next property, issue node next, points to the next node in the linked list. If next is null, it means that this is the last node in the list. Constructor Public issue node. When you create a new issue node, you pass in an issue. This issue gets stored in the data property. Next is automatically set to null. Since the next node doesn't point anywhere yet, it adds in to the list. And then the last class, report issues form. In short, a Windows form screen for users to report a municipal issue. It collects location, category, description, optional attachments, and it shows progress and nudges to guide the user then to the repository. Now, the showcasing of the project. So we are welcome to the main menu. The report issues is enabled for the user to report issues, which is what we should be demonstrating. The other two parts of the POE are disabled, which is the local events and announcement feature, and the service request status, which is disabled for this demonstration. We click the report issues, which as you see works and takes us to the report issues page. Here we have the data fields, the location input to enter the issues location. We'll say uh, main road observatory. Uh, then the category selection, where you are met with the different options as stated: sanitation, roads, water and utilities, electricity, parking, and others. We'll just choose roads for this. Then the descriptions box, where you write your detailed description of what is wrong. We'll say potholes, potholes uh, in the road, and road is um, caving. Then you get to the attachments option, um, where you can add your different types of files. You can either add image, an image, um, an image for this part, and as you can see, the progression bar is 100% filled, which indicates how far you are with the application as long as you fill all four fields. Um, As you can see, the engagement features have dynamic label providing encouraging messages, or a progress bar showing the reporting progress. So after you have 100% filled the progression bar, you can press submit, which you can actually see that it has user feedback showing that you have successfully submitted your report. And then you can press OK, and then back to the menu button to the main menus page. To also showcase the other part of the user feedback, for example, if you try to submit a report without entering any fields, it'll give you an error message to show you what you need to enter in order to submit the report. So if we enter a suburb, say San Santon, a place rather, and then we try to submit again, we'll get an error message stating that please select the category and enter your description, and then obviously your attachment of whatever type of document for that issue. So let's fill it in again. This time we will choose electricity, description, um, no power, and electrical fire. And we can obviously attach image or document by opening the file dialog. This will just attach a random PDF. And as you can see again, the progression bar has been fully filled, and therefore we can submit um, an issue. And as we said, we are again greeted by the user feedback of thank you for submitting your report, which means your report has been submitted. And you can see it counts how many reports have been submitted, which is 2. And for the data handling part, issues are stored in a list data structure for easy management. Then design considerations. I went for consistency, for uniform color schemes and layouts across the forms, clarity, clear labels, buttons and instructions, user feedback, the message box to alert for success or errors, as we have seen, responsiveness, forms adapt to different screen sizes, event handling, buttons and controls respond seamlessly to user interactions. And lastly, for future enhancements, I will implement the local events and announcements and implement service request and status tracking, add a database integration for persistent storage of reported issues, and lastly, include more sophisticated engagement features like progress tracking or gamification. Thank you for your attention and for taking the time to watch my YouTube demonstration of my part 1.